So today we're going to cover section 4. Today we're going to talk about perimeter and area in the coordinate plane, and we're also going to learn how to classify polygons. But before we can learn how to classify them, we need to find out what the definition of a polygon is. And the word polygon means many angles. And a polygon is a closed plane figure that's formed by coplanar segments, which are called sides. Now, the smallest polygon that we can create that's a closed figure is going to be a triangle. This will be the smallest polygon that we can create. Now, these three characteristics or these three things need to happen in order for a figure to be a polygon. So each side must intersect exactly two sides, one at each endpoint. So this side right up here in the triangle, notice it's intersecting this side and this side right here and here. So each side must intersect exactly two sides, one at each endpoint. No two sides can have a common endpoint that's collinear. So for example, I couldn't have a third point on the side of this triangle. It can only be formed by non-collinear points. And then each endpoint of a side is going to be called the vertex of the polygon. So we'll be seeing points, like let's say this is point A, B, and C. A, B, and C are also the vertices of that triangle. So let's look at some pictures and let's decide, are these polygons or not? So for the first figure, A, notice that it's going to satisfy all three conditions. We've got our vertices. Notice that these sides, this side, for example, is intersecting with this side and this side. It's not intersecting more than two sides. It's also a closed figure. So figure A here, yes, this is a polygon. However, figure B, it's got a hole in it. It's got an opening here. So because this side is not intersecting two other sides, this one is not a polygon. It's got an opening in it. It's got to be a closed figure. Figure C, notice on this one, it's intersecting too many sides. So for example, we've got a bunch of collinear points here. That would first make it not a polygon. Or if you looked and saw that this side here is intersecting this one, and this one, it can only intersect two. So this one is not a polygon as well. But as soon as we took away all those inside lines, figure D is a polygon. It's a closed figure. This side is only intersecting here and here, and there are no collinear points now. And then this figure here, notice it's not a closed figure. The sides are not intersecting at both endpoints, so this one is not a polygon. Now coming up, we're going to be learning some vocabulary terms, concave and convex. Figure D here, if you notice this star-looking shape, it looks like this side is caving in. So that's one way I think of concave, but we're going to see that definition coming up in a minute. Now, another thing, characteristic of a polygon is you cannot have rounded sides or curved sides. So for example, if I drew something like this and it's got like a little dome, this would not be a polygon because you can't have a curved side. So a convex polygon has no line that's going to contain the side of a polygon that contains a point in the interior of the polygon. So for example, if I were to highlight the inside of this polygon, and then if I were to draw a line on top of any of the sides, this red line that I'm tracing over this side does not go into the green portion. or if I trace it over this side, notice it never enters into the interior, making this polygon convex. Now, another way to think of it is that all of the vertices where those two sides meet, they're all pointing outwards. But if we have a side that's going to cave in, then it's going to be concave, and that'll be on the next slide. All three of these are convex polygons. And notice if I were to trace over all of these sides, these red lines never enter into the polygon, making it convex. Concave has a line that contains a side of the polygon. So if I were to take a side and draw a red line, let me go ahead so this is the interior of this polygon, all the green. And you don't need to have all of the sides to do this. As soon as you find one that caves in, then you're going to say that it's concave. So notice if I were to trace over this side right here, notice the red line is now in the green, making it concave. So again, another way to think of it is this side right here looks like it's caving in. So that's a little clue for me that something would be concave if one of the sides looks like it's going to the inside. But a way to officially check it is to trace over the sides, and if it forms a line and it goes into the green, the interior there, then it's concave. If it doesn't, then it's convex. Okay, so next we're going to classify or come up with the names for the different polygons. So again, the smallest polygon there is the three-sided polygon, and it's called a triangle. Now we're going to have chapters that are going to specifically talk about triangles. We're going to get really in depth with the triangles. We'll also have a chapter dedicated to just quadrilaterals, and those are the four-sided figures. Specific quadrilaterals could be a square, a rectangle, and those are just two of them. But for now, if I ask you to give me the name of a four-sided polygon, you're going to tell me quadrilateral. When it's a five-sided polygon, it's called a pentagon. 6 sides is a hexagon, and the way that I remember hexagon is the number 6, or the word 6, has an X in it, and so does hexagon. Because the next name for the 7-sided is called a heptagon, so 2 H words. Yes. Then the next one is the 8-sided figure. It's called an octagon. I remember that because I think of an octopus and it has 8 arms. So an octagon has 8 sides and 8 angles. The 9-sided, not so common, but again, you can sort of use the word 9 to help you remember, because the name for the 9-sided figure is a nonagon, and notice they both have 2 N's in there. They've just changed the vowel there. 10-sided figure is a decagon. I remember that because I know that 10 years is a decade. Okay, so again, a 10-sided figure is a decagon, think decade. 12-sided is dodecagon, and as you notice, the 11 was missing. So the only ones you're going to be responsible for are the ones that I've listed here. Any other type of polygon, I'm just going to put the number, and if it's 11 sides, then you're just going to describe it as an 11-gon. If it's got 100 sides, then you would just put 100-gon. So any of the other numbers, just put -gon after the number. So for each one of these pictures, they want us to tell whether or not it's a polygon. If it's a polygon, then we have to classify it as convex or concave. Now, if it's not a polygon, we just say not a polygon. So for the first one, is that a polygon? No. If we were to separate it, it would be, but these are actually 2 closed figures, so as it's pictured, it's not a polygon. Now, if I were to take out that line in the middle, then this would be a polygon. So if you picture it this way, And then this one would actually be a concave polygon. But this one is not. The next one, is it a polygon? Yes. Do you know what kind of polygon it is? How many sides are there? 6. What's a 6-sided polygon? Hexagon. Nice. Okay. Is this concave or convex? Convex. Good. All of those vertices are pointing out. And again, you could do that little check and make sure that none of these lines go into the interior, and they don't. Perfect. Now this next one's kind of hard to see. This is supposed to be a curved side here. Can a polygon have a curved side? No. So this one is not a polygon, and because it's not a polygon, we're not classifying. And then the last one, is that one a polygon? Yes, it is. Okay, and it's actually, if you draw a line, notice this side goes into it, so this is concave. This time they want me, these are all polygons. So this time they want us to classify it. So we got to give the name now. And then also, again, state if it's concave or convex. So let's go ahead and count up our sides here. We have 1, 2, 3, 4, 5, 6 sides. And a 6-sided figure we just saw was a hexagon. And is this concave or convex? Beautiful. Now, notice all of the congruency marks on this. This is showing me that all 6 sides have the same congruency mark, making all those sides the same length. They also have congruency marks at each of the vertices. So all of these are angles of the hexagon, and notice they all have the same markings, making all those angles congruent. So whenever all of the sides and all of the angles in a polygon are the same, they're congruent. Another name that we could describe a polygon is, we would see the word regular put in front of the polygon name. So whenever you see the word regular in front of a polygon name, just know that that means all angles and all sides are congruent. The next figure, how many sides do you count? 4, making this a quadrilateral. And more specifically coming up, and we don't need to know this right now, this is actually a parallelogram. Okay? Is this parallelogram or this quadrilateral concave or convex? Beautiful. And then the last one, we're going to count up all these sides. There's a bunch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 11, 12. What is the 12-sided figure called? Dodecagon. And is this concave or convex? Concave. You guys got this. All right. So again, if you just drew the line on top of this, see how it goes into the inside. Perfect. So for the next one, we're finding perimeter and area in the coordinate plane. So what we're going to be doing in the homework is you're going to be given order pairs. You're going to have to graph the order pairs and then find the lengths of the sides, either by counting the squares, if the segments are horizontal or vertical. If they're diagonal, you're going to need to use the distance formula. So for perimeter, when it's a triangle, all you're doing is adding up the 3 sides. So in this triangle, they have A, B, and C. You would just add those. The height would not be part of the perimeter. It's not an outside edge. You would use the H there. That's the height of the triangle. You would use that for the area formula. So the formula for area of a triangle is 1/2 base times height. You may also have memorized it as base times height divided by 2. Either way, you would still get the same answer. Always remember that the height of the triangle is going to be indicated by a right angle. It's always the perpendicular segment. Then the next figure that's here is a square. And when we have a square, all four sides are going to be the same length. So to find the perimeter, you can either find the length, take one of the lengths of the sides and times it by 4, or just know that all of these have the same. So you could have also done side plus side plus side plus side, but honestly, it's a lot faster just to take the side length and times it by 4. The area formula for a square is just side times side. Now, technically, you could do length times width or base times height. The only difference is that number will be the same for both the length and the width. The last figure that's here is a rectangle, and you can either memorize the perimeter formula, like the one that they have there, and this is probably the common one that you used in your algebra class, because a lot of times when they're teaching you to solve two-step equations, they're actually making you turn a word problem into this equation. Now, we could have also found the perimeter of a rectangle by also doing length plus width plus width, or you might also see it as taking the length and the width and adding them, and then timesing that answer by 2. All of these also would give you the perimeter of a rectangle. The formula for area of a rectangle, length times width. In middle school, you might have also learned it as base times height. Either way will work. So this could have also been labeled as a base, and this could have been labeled as a height. Now, whenever you calculate perimeter or area of these shapes, they're going to be, perimeter is always going to be measured in linear units. And what I mean by linear units, I'm referring to things like inches, feet, meters, yards. These are linear measures. When we do area, it's going to have that linear measure squared. So area, the units are always going to be squared units. So you could have inches squared, like that, or sometimes they'll put SQIN. So just be able to recognize it, or even spell out the word square inches. So area is always the unit squared. Perimeter are going to be whatever they give it to you as. If it's inches, you would label it as inches. So for example, if I gave you a rectangle, and I tell you it's a 3 by 8, and these are inches. If I ask you to find perimeter, we could do 2 times 3, use the formula that's up there. So this would be width, this would be length. So 2 times the length, let me fix this. So 2 times the length plus 2 times the width could give us perimeter. So 2 times 8 plus 2 times 3, and this would give me 16 plus 6, and I would get 22. Now you could have also realized that this side will be 8, this will be 3. You could also do 3 plus 3 plus 8 plus 8 and still get 22. And again, the units here are whatever they were in the problem. So 22 inches. However, if it's area is going to be length times width or base times height. So you would do 3 times 8 and it would be 24 inches squared. So the units on area are going to be squared. Okay, so I'm going to go ahead and graph the ordered pairs. They want me to find the perimeter of triangle ABC. Now notice the little picture of the triangle here. So if I were to have, remember you can name a plane with 3 letters. So whenever they're referring to a triangle, they're either going to write the word triangle and the 3 letters, or what you're going to see most often is they're just going to put a picture of the triangle and then put the 3 letters which represent the 3 vertices. So I'm going to go ahead and graph these 3 ordered pairs, and then I'm going to connect the points, and it's going to form a triangle. So for point A, it's the order pair -2, +3. And then for B, 3, -3. And then for C, -2, -3. So now I can connect my points. I'm going to also label them A, B, and C. So now to find the perimeter of this triangle, what I need to do is add up all the sides. I need to add side AC plus BC plus AB. Now, side AC is this segment that's right here, and it's vertical. I can either just count the squares since I've got it graphed nice and pretty, or I could do the subtraction. And then side BC is right here. It's horizontal. I could also count the squares. However, for side AB, this one I need to do the distance formula. So let's do AC. So for AC, you can either count the squares. It's got 1, 2, 3, 4, 5, 6. So it has a side length of 6. Now, you could have also taken the order pairs for AC, and the coordinate or the X is the same, so get rid of that. And then you would just subtract 3 minus -3, absolute value it. Key flip change, 6. So the length of AC is going to be 6. Then I can do the same thing for BC. I could either just count the boxes, 1, 2, 3, 4, 5. So BC has a length of 5. And again, if I did the subtraction, order pair B is 3, -3, C, -2, -3. Get rid of the part that is the same. So 3 minus -2 becomes, keep flip change, 3 plus 2. And I get the same answer that I got when I just counted the little squares. So this is BC. Now, for AB, though, we have to do the distance formula. So for AB, we're going to be using x sub 2 minus x sub 1 squared, and then subtract the y's, and it's all under the square root. So the order pair for A, -2, 3. Order pair for B, 3, -3. So I'm going to go ahead and assign my x1, y1 to one of the order pairs and do the same thing for the other one. And it doesn't matter which one. So I'm going to say this is x1, y1, and this will be x2, y2. Going to plug it into the formula. So I get 3 minus -2 squared plus -3 minus 3 squared, and it's all under the square root. This becomes 3 plus 2. This becomes -6. This becomes 5. And now I'm going to square the 5, square the -6, add them, and I get 61. Now, in your homework, since we're not doing the big ideas yet, you're going to leave it in simplest radical form. So what we'll do here, remember, we were supposed to be adding the 3 sides. Yes. So now, I need to find perimeter. Remember, perimeter, we're adding up all the sides. So I need to go and add AC, BC, and then the answer I just got for AB. So AC was 6, BC was 5, AB square root 61. Now, if you're not using a calculator, only thing you can add is 6 plus 5, and then leave the square root of 61. Now, if you were using a calculator, then you would use your calculator, and more than likely they'll say round to the tenths place. So when you square root this on your calculator, you're going to get 7.8. And then if they said using your calculator and round to the tenths place, 18.8 units. And if they didn't say use a calculator, you would have left it like this. So be aware of both ways. Traditionally, we didn't use calculators, so we would have left it the first way. But now that we've transitioned to the online homework, a lot of the questions need a calculator. So you would have just done it this way and left it as 18.8. Now, if this would have asked me to find the area of this, whenever you have a horizontal and a vertical line and they meet, this is forming a right angle. So if this said find the area, this would have been my height and the 5 would be my base. So if they said area for this question, I would have done base times height divide by 2, or 1/2 base height. So 5 times 6 divide by 2, 30 over 2, and this would have been 15 units squared if it asked for the area. So when it's a right triangle like this, and you have a horizontal and a vertical side, the area is a lot easier to find. We wouldn't have even had to find that AB because we're not going to use it for area. Now the next one, they're asking us to find area. And again, if it were perimeter, we would have had to have done the distance formula twice. But let's go ahead and graph the next one. Again, this time they're talking about triangle DEF. So let's graph the order pairs. D is the order pair 1, positive 3. E is 4, negative 3. And F is negative 4, negative 3. So right here. So if I connect my points, if it said perimeter, I would have had to have done the distance formula for DE and DF. However, it wants area for this one. So remember your area formula, 1/2 base times height, or base times height divide by 2. So in this picture, my base is down here at the bottom. This is my base. Now the height of the triangle is not DE or DF. Remember, the height is always the perpendicular segment, the segment that goes straight up and down. So my height is going to come from this tippy top point of D and go down here. And because it's just a vertical line, I can just count the squares. Or I can do the subtraction, either way. But on this one, I'm just going to count the squares. So this has, let me go ahead here in a different color, 1, 2, 3, 4, 5, 6. So it's got a height of 6. So my H is 6. My base, I can do the same thing. I could count 1, 2, 3, 4, 5, 6, 7, 8. My base is going to be 8. Now, for the base, since we had the two order pairs, we could have also taken E and F and subtracted. So E was 4, negative 3. F was negative 4, negative 3. Get rid of the one that was the same. And now subtract. Keep, change, flip. And you get 8 either way. So again, if you're given a nice piece of graph paper or a nice coordinate plane in Notability, you can graph it and just count the squares whenever the side or the height is horizontal or vertical. If it's diagonal, you have to do the distance formula. So now what I'm going to do is I'm going to plug in my numbers. So 1/2, my base was 8, my height was 6. So half of 8 is 4, and then 4 times 6 is 24. And again, since there weren't any labels as inches or feet, whenever it's order pairs like this, it's going to be units. And you can either write it like that, or you could spell it out, square units. So this is the end of the notes for 1-4, covering the different polygon names and finding area and perimeter when you're given coordinates and having to graph them, and then finding the lengths of the sides. Remember, perimeter of any shape, you add up all the sides. Area, use whatever formula is appropriate.